Let's dive right into this explainer. Today, we're breaking down Google's 2026 Cloud Next announcement and figuring out exactly what it means for your TCO, your total cost of ownership. If you're operating in the enterprise space right now, you already know the deal. Keeping your compute costs under control has suddenly become the absolute hardest part of scaling AI. I mean, we're talking about basic bottom-line survival here. So today, we're unpacking a massive hardware shift that's aiming to change those economics from the ground up.
So let me ask you, is AI inference just completely destroying your gross margins? If you're an enterprise CFO, or maybe an AI architect scaling agentic workflows, and by that I mean those multi-step AI tasks that act totally on their own to solve complex problems, you are definitely feeling the financial burn of serving these models. We're officially past the days where training the model was your biggest expense. Now, it's the day-to-day operation. The inference phase, where the AI is actually talking to your users, is what's quietly and aggressively eating away at your profitability.
And this bleeding is largely coming from traditional unified chips. They are heavily over-provisioned for raw compute, but completely starved for memory. Across the board, we're seeing these severe KV cache memory bottlenecks. Think of KV cache like the AI's short-term working memory. When you ask it to read, say, a massive financial document, it literally runs out of memory before it even taps into its available compute power. It's frustrating, and honestly, it's incredibly wasteful. Add in the premium pricing lock-in from the dominant ecosystems and those latency failures when agent loops just time out, well, you've got a perfect storm for totally wasted capital.
Here's our roadmap for today. 1. The AI inference cost crisis. 2. The great hardware split. 3. Unpacking the ROI math. 4. Challenging NVIDIA's market moat. And finally, 5. The enterprise TCO verdict.
Section 1. The AI inference cost crisis.
The core problem destroying budgets in 2026 is that running inference for millions of concurrent users or deploying thousands of autonomous agents on chips originally designed for heavy training leaves wildly expensive silicon just sitting there idle. It's exactly like buying a fleet of Formula One race cars just to deliver local groceries. Sure, they're super fast, but the math just doesn't make any sense. You're paying absolute top dollar for a massive training-level architecture, but the everyday task of serving a language model simply doesn't use it efficiently. You're paying for the race car, but you're literally stuck in school zone traffic.
Section 2. The great hardware split.
Looking back to 2015, Google's TPU v1 was actually inference only, but by 2017, with the v2, the unified era began. Everything was built on one type of multi-purpose chip, and that worked perfectly fine for a while. But fast forward to 2025's TPU v7, Ironwood, and the whole industry hit a massive, expensive brick wall with those memory bottlenecks. The models just got too big and context windows got way too long. The solution? Google's April 2026 Cloud Next announcement, where they fundamentally bifurcated their silicon lineup into the 8T and the 8i.
By officially splitting the hardware, Google created a highly targeted financial rescue package. In the old unified paradigm, you inevitably waste high-end compute on memory-bound serving tasks, which needlessly drives up your CapEx, your upfront capital expenditures. But this new bifurcated strategy changes the game entirely. It gives you the A8, dedicated exclusively to the heavy lifting of model training. And more importantly for your day-to-day margins, it introduces the AI, a chip purpose-built purely to optimize low-latency inference. You literally buy exactly what you need for the exact job it's doing.
Section 3. Unpacking the ROI math.
Now, Google is claiming the TPU 8i delivers up to an 80% performance per dollar improvement over the previous Ironwood generation. Let's just pause and really think about that. An 80% leap in efficiency? That's not just some marginal, incremental upgrade you gloss over in a quarterly report. It's an absolute earthquake that fundamentally rewrites how you should project your infrastructure budget for the next few years.
When you translate those dense technical specs into actual business terms, you're effectively doubling your operational throughput without adding a single cent to your cloud budget. As 9 to 5 Google pointed out right after the keynote, this improvement means companies can serve nearly twice the customer volume at the exact same cost. For any business out there scaling a digital product, that is a massive margin-saving reality.
This massive 384 MB SRAM isn't just a vanity spec to throw around. It's the literal mechanism that cures memory bottlenecks for agentic AI. By tripling the on-chip memory compared to Ironwood, the 8i securely holds those massive KV caches we talked about. It stops your models from running out of short-term memory before they run out of compute power. Practically speaking, it drastically cuts down the money you have to spend shuffling data back and forth across your network. Your operational expenses on bandwidth just plummet because the memory is exactly where it needs to be, right there on the chip.
But memory isn't the only bottleneck, right? Latency is just as expensive. Enter the board fly topology. This is a totally novel networking architecture that cuts the maximum network diameter by 56%, delivering data routing that is 5 times faster. AwesomeAgents.ai noted how incredibly critical this is. Imagine an AI agent taking 10 multi-step actions to successfully book you a multi-city flight and a hotel. If each step takes 2 seconds just to route the data, the user gives up and the process financially fails. The ADI ensures those agentic loops happen in a fraction of the time, keeping the user engaged and your compute costs remarkably low.
Memory and latency are one thing, but raw power consumption is another beast entirely. Data centers are incredibly power-hungry, and energy constraints are a very real threat to scaling up. But the TPU-8i offers a 2x performance per watt efficiency gain over the Ironwood baseline. You are halving your energy consumption for the exact same performance. That's a massive win for your OpEx. When you're operating at enterprise scale, this line item alone could completely justify a hardware migration.
Section 4. Challenging NVIDIA's market moat.
Locking into premium ecosystems essentially guarantees a high total cost of ownership. Take a look at unified architectures like NVIDIA's B200. You pay a massive premium up front, what people often call the CUDA tax, and then you still experience high compute waste during inference. The bifurcated TPU-8i undercuts this specifically for mixture of experts models, like GPT-4, which only activate specific parts of their artificial brain when needed. This approach matches perfectly with the 8i's targeted inference OpEx, giving you 100% purpose-built utilization.
You absolutely know the math is undeniable when NVIDIA's own biggest customer, OpenAI, actively diversifies to buy Google's compute just to save their own margins. As Techie reported during Cloud Next, Google just put a price on NVIDIA's moat. Securing multi-gigawatt allocations from titans like Anthropic, Meta, and OpenAI is a massive plot twist in these hardware wars. When the biggest, most resource-rich players in the world completely shift their core infrastructure strategy to save money, everyone else in the enterprise space needs to take notice immediately.
Section 5. The Enterprise TCO Verdict. So here is your definitive action plan. First, aggressively audit your current ratio of training versus inference workloads. You have to know your exact numbers to stop the financial bleeding. Second, calculate the actual financial penalty you're paying right now for those KV cache memory bottlenecks, because every single time an agent times out, you're losing money. Finally, compare the massive upfront capex of unified chips against the targeted ongoing OpEx of Google's AT and 8i split. By separating these workloads, you can finally model the exact dollar value of lower latency.
Given the 80% return on investment boost, the tripled SRAM, and the massive latency reductions of the board fly topology, we are left with one critical final question. Is sticking with a unified chip paradigm a financial risk your enterprise can actually afford to take? Because when the math changes this drastically and the biggest players in the industry pivot, doing nothing might just be the most expensive decision your business could ever make.